In today's notes, we're going to look at transformations of points without a graph. So far we've been looking at graphing functions based on transformations that were given. So for instance, last time we were looking at transformations on Move the Monster and Explore Transformations, where we were given some kind of function and we were told to do certain transformations. What we're doing now is we're doing the same exact thing. However, instead of us doing this on a graph with a bunch of different points, at least for this first question, we're just doing it with one point. So it says, if the point 2, 3 is on f of x, what will the coordinates become after each of the following transformations? So for all of the problems here, it looks like there's a transformation that's occurring for every single one of the problems. We need to figure out what is the new point going to become from 2, 3 based on the transformations that we have here. So I'm not going to do every single question here, but I'll do the ones that I'm highlighting. And after we finish, I'll give you guys a couple to try, and then we'll move on to the next section. So before we do anything, even though I've highlighted which ones I'm about to do, I want you, on top of the respective questions, all of them actually, I just want you to determine, is the transformation that's occurring happening inside the parentheses with x or outside the parentheses away from x? So for instance, for letter A here, this one is an outside transformation because the 2 is outside of f of x. For letter E, for instance, this one is a inside transformation because literally inside of f of x, it's no longer just f of x. We now have a negative inside. And then for instance, for letter I, this one actually has 2 different transformations. It has one inside and one outside. So on top of it, I'm going to put both. Keep in mind, under each of these problems, I'm kind of writing it as small as possible because I am going to put work underneath them. So if you want to maybe write these kind of small or make a list over to the side in the margin, feel free to do so. But right now I want you to pause the video and I want you to label all of these questions. Are these transformations occurring inside or outside of your parentheses? So we have everything labeled. So we have the different transformations that are occurring. This is actually going to be helpful for you when you're trying to solve each of the problems to figure out what your new coordinate is going to be. So we're going to look at letter A to start us off. So for letter A, it says we are going to do the outside transformation on f of x, and f of x is this point here. Okay, let's think back to what we did on this page. When there was some change that was inside the parentheses with x, we only changed the x values. If we had a transformation that was occurring outside of f of x, whether it was in front of the f of x or behind it, we always change the y value. So that's the same process we're going to follow here. So for this question, even though I have 2 coordinates for this, I'm only going to change the y value because this 2 represents a change in your y. So we're going to have 2 times our y value, whatever that y value is, and that y value in this case is 3. So my new y value is going to become 6. So we're going to write our new coordinate as 2, 6. That's my new point. That's all we're doing. So let's do the same thing for letter B. For letter B, again, this one is asking you to change something that's outside. And again, we're transforming this point. When you have a transformation that's occurring outside of your function of x, we are only going to be changing, again, the y value. We did this last class. Every time we make a transformation, we always want to see, is it going to affect the x's or is it going to affect the y's? So over here, I'm going to rewrite this as I'm going to take all of my y's and add 1. Well, for us, there's only one y, and that y value is 3. So we're going to take 3 and add 1 to that, which is going to give me 4. So my new point is 2, 4. That's my answer. I don't think I had any more on this row, but I do have some on this row. Let's look at the ones that are inside. Okay, for inside, this one's a little different, and you might want to remember what we did last time. Anytime we have something inside your parentheses, we take that value and we set it equal to all of the original x's. Well, in this case, for the problem that we're looking at now, there's only one x. It's literally the point 2, 3. So I need to take this value, 2, and set it equal to whatever's in the parentheses. So over here to the side of my margin, I'm going to rewrite negative x, and we're going to set that equal to 2. All I need to do from here is solve. So I'm going to divide both sides by -1. X will equal -2. So my new x coordinate is going to be -2. If you look here, there's nothing that's happening outside, so I'm just going to keep the same y, which is 3. We're going to do the same thing for letter F. For letter F again, we're still looking at that only point 2, 3, and I'm now going to set x minus 1 equal to 2. I'm going to add 1 to each side, so x will equal 3. So my new coordinate is going to be 3, 3. This is my answer. Forgot to highlight letter B. And then the last couple questions, let's look at H. H again, okay, this one's an outside transformation. We're going to take y, subtract it from 3. And if you're like, what y are we looking at again? We're still looking at this same point, the same x and y. So we're going to take that 3, which is our y value, and we're going to subtract 3. 3 minus 3 is 0. So from here, all I'm going to do is write my coordinate, and that's going to be 2, 0. And then the last question is asking us to figure out what the transformation is going to happen when both the x and the y are being changed. So for this question, I'm going to set x plus 2 equal to 2, which is the original x. And we're going to set negative y minus 1 for my y value. I just need to take that y and substitute it in. So for the x, we're just going to subtract 2 on each side. So x will equal 0. So over here to the side, I'm going to put my coordinate, 0, comma. My y is going to become negative parentheses 3 minus 1. Well, negative 3 minus 1 is going to give me negative 4. So my new coordinate is going to be 0, negative 4. And it's literally following the same process that we just did on the other page. It's just not as nicely organized as we've seen it before, but it's still following the exact same process. So right now, I'm going to highlight a few questions in green that I want you to try. I want you to try right now letters C, D, and K. Pause the video right now and do letters C, D, and K. So for questions C, D, and K, I'm not going to post the answers for these questions in this video. It might be that you might have a checking for understanding assignment to do after this assignment is done, or after these notes are done. So if I were you, check Canvas, see if you have an assignment to do, because these questions will likely be on there. If this is a later video and you do not have a checking for understanding assignment, just check the Google Drive page or wherever I've told you to check your answers, and you should see the answer key and be able to check your answers that way. Let's go ahead and keep moving. For numbers 2 and 3, I'm not going to go through those. Those are just extra practice questions to help you study. We're going to go ahead and look at the bottom portion here. Questions 4 all the way to the next page, which is up to number 10. So I'm not going to do all of the questions here. I will do questions 6, 7, and 8. It says a continuous function f of x contains the data points in the table shown here. If the following transformations were performed on f of x, what data tables would be produced? Okay, so it's pretty much asking us to do the exact same thing that we did on the Explore Transformations Move the Monster activity, but it's not asking us to graph it, which, I mean, it's kind of nice, I guess. But all we're going to do for all of these questions is we're going to create this transformation table, and that's it. That's all I really need to do. So I will mention you don't have a lot of space on this page. If I were you, the backs of your page should be completely blank. So you can flip your paper over and use that. Or you can use extra scratch paper, lined paper if you have it, extra printer paper. If you need to, pause the video, check with your teacher and see if they have any extra paper. But you want to make sure that you have enough space to be organized and to keep your work close by. Especially since I have an iPad, I can kind of cheat and zoom in. So I'm probably going to do that for a couple of questions. So I have my table here, and I need to do the following transformation for number 6. So for question number 6, I'm going to go ahead and rewrite my table like I normally do. And when I do so, I'm going to notice that this 2x is in the parentheses, so I need to set that equal to all of the original x's. So we're going to rewrite our table. I'm going to put 2x will equal literally the very first column of x's. Every single one of these x's here, I'm going to set equal to 2x. So we're going to make this -7. 2x will equal -4, all the way down to +6. Once I simplify each of these, I'll have my new column of x's. And then I have to make my table for my y. So in the y's, there's nothing outside in front. There is something behind this 2x. So for every single y that I have in my original table, I'm going to add 4. So we're going to take all of those y's and we're going to add 4. Notice that I'm trying to keep each of these in line with the number next to it. So if you want to draw horizontal lines going through all of these, you can, just to separate them. But I can kind of see where I'm going with each question. From here, we're just going to simplify. So I'm going to divide these by 2. So this will give me -7/2, -2, -1, -1/2, 1, 3/2, 5/2, and 3. For my y column, I'm now going to simplify. So -2 plus 4 is going to give me 2. -6 plus 4 is -2. -15 plus 4 is -11. We're going to have -3, +3, 6, 7, and 12. If I needed to plot all of these points, I would know exactly which points go where. Each of these that I'm underlining are your coordinates for their respective x's and y's. So each x on the left goes to some y value on the right. That's all we're doing. So for questions 7 and 8, I am going to go through those. But before I go through questions 7 and 8, I want you to try them without me. So right now, pause the video and do questions 7 and 8. Just a quick check-in. I have set each of the original x's equal to x minus 2 and solved in red. So this column here is all of the answers that I've calculated. And then for the y's, I want you to keep in mind, I purposely kind of stopped here before I continued. Even though we know that half of 2 is going to give me 1, when you add 5 to that, that will give me 6. Same thing when you have half of 6, that's 3. Negative times negative is positive, that's why I'm not worried about that. And then 3 plus 5 is going to give me 8. I want you to keep in mind that for this question here, it's a fraction. That -1/2 times -15 is going to give you +15/2. Your responsibility is to make this into a fraction and then simplify. If you want to, especially for this, because I understand it's kind of annoying. If you want to write these in decimal form, you can, but be careful because on tests and quizzes, I will ask that you write them in simplified improper fraction form. So if you haven't finished this question, pause the video, finish up number 7. I'll unpause it, I'll show you the answer, and then we'll move on to number 8. So I have all of my y's listed. Notice that I did write them in decimal form because let's be honest, most of y'all will write them in decimal form. And plus 0.5 isn't that difficult. We can easily write that as a fraction if needed. So keep in mind, if I asked you to graph this on a test or quiz, each of these that I'm kind of putting on a line together, these are the points that go together. So make sure that you keep in mind, or if you need to draw those lines on your paper, that you do so. You want to see each value, each x, correspond with its appropriate y. Okay, so that's all the answers for number 7. Let's go ahead and look at number 8. Again, same thing. Pause the video, do number 8, unpause it when you're ready to see at least the x's first, and then I'll do the y's. Okay, so we have it a little out of focus, but we got it. So for our question 8, we have, I'll zoom back out. We have all of these x's and y's, so take a second and check. For the y's, notice that I haven't finished solving. You're going to take 3, positive 3. You're going to do the absolute value of y. So each of the original y's you need to plug in, take the absolute value, and then simplify. So when you're ready, pause the video one more time, and then when you unpause it, you'll be able to see your y values. And there it is. All of our y values are here. So that's pretty much it for this first page. So all of the things that we've looked at are pretty much a review of what we've already seen. So we've already noticed how to take points and get them into new ones based on the transformation that's happening either inside the parentheses or outside the parentheses. Questions 9 and 10 at the top of the next page are over the exact same concept from the last page, so it's still following the same stuff. Questions 11 through 16 are a little different. I'm going to do a few questions with you, and then you're going to do some questions on your own. Those questions you do on your own, if you have a checking for understanding, will be asked to give the answer on that checking for understanding assignment. So let's read the question. It says, each of the following tables show data points contained in functions that are transformations of f of x. Write the equation of each table in terms of f of x. So what it's pretty much saying is they've taken this table here and they've performed a transformation on it. That transformation is representative by all of the questions or tables that you see for questions 11 through 16. So the first thing I'm going to do is I'm actually going to use this space on the left-hand side, and I'm going to rewrite the f of x table from that very first page. So I'm going to rewrite it. It's going to be x and f of x, and this will prevent you from having to keep flipping back and forth. It's -7, -4, all the way down to 6. And then for my f of x, all of these. So we have our f of x table. We know what the original transformation is. What I'm going to do now is I'm going to try to figure out how did they get from this table here to this table and all of the other tables. So for all of the tables for 11 through 16. So I will likely need a separate sheet of paper to actually show my work, which I will use in a second. But before I do that, remember, we're just trying to write the equation for each table in terms of f of x. Let's just look at the f of x table and the k of x table because we're looking at number 11 first. I want to know, does anything change from the x's in the f of x table to the x's in the k of x table? Does anything change? Without even having to get too far into it, yes, it does change. So I'm going to definitely say yes. So right next to 11, I'm going to make a little note that we are going to change things inside of your parentheses. If you're like, wait, why are we doing inside? If you look back to the last page that we were just on, anytime we had a transformation inside our parentheses for the x's, we always had to set them equal to the original in order to figure out how our new graph was going to look. So everything that we have so far for question 11, this is an inside transformation. So we're going to have to change something inside that parentheses with f of x. For the f of x column, that's the y's. How do those y's change, if at all, with the k of x? Those are y's as well. Well, hopefully you notice all of these y's and all of these y's are the exact same. So luckily for us, there's only an inside transformation that's happening. It's only going to affect all of the values inside of your parentheses. So the y values will not be affected. Okay, what we're going to do now is I'm going to switch the page and I'm just going to recopy the x's for the f of x column and the x's for the k of x column. I'm not going to lie, I already did it. So I purposely wrote it. There's methods to my madness. These are the new and these are the original. These are the x changes only. We're only changing the x's here. So how did we get from the new to the original? If you're like, wait, why are we looking at the new column and comparing it to the original? Here's why. Remember how on the last page that we were doing, the very first page of this packet, we had to solve each of these equations? We had to do an inverse operation on the right hand or left hand side to get the answer on the right. So that's what I'm pretty much compensating for on this page here. By comparing the new to the original, I'm compensating for that inverse operation that I have to do. So that's why I'm putting the new first and then the original. So now we just need to have a discussion. How am I going to get from negative 14 to negative 7? I could divide by 2. If I divide it by 2 or multiply it by 1/2, that'll be able to give me my answer. What if I went from 8 to negative 4? If I can find a constant change for every single one of these from new to the original, I'll be able to find my transformation. Okay, from 8 to negative 4, dividing it by 2 or multiplying it by 1/2 will give me that answer. Let's do one more. From negative 4 to negative 2, you want to make sure the signs stay the same, so it's still negative. And to get from 4 to 2, again, you're just going to take half of that or divide it by 2. Double check the remainder of this column. If I was to go from negative 2 to negative 1, 4 to 2, 6 to 3, 10 to 5, and 12 to 6, will I just be able to take half of each of those numbers? The answer is yes. I can definitely take half of each of those numbers in order to get to my original value. So what they did, all they did, was they pretty much took half of the original parent function and they solved it. And if you're like, wait, they can't take half of it. Yes, they can, guys. What they did was they took f of 1/2 of x. Okay, let's think about it. If they have f of 1/2 of x, that means they took this 1/2 x and they set it equal to 7, 4, 2, all the way down to 6. So let's just try that. We're just going to do that for one question just to show you what they're thinking. And this is supposed to be a negative 7. Okay, you guys tell me, how would they solve this? Well, they would just multiply both sides by 2 because the inverse of doing a half or dividing by 2 is just multiply. These cancel, which will leave you with x equals negative 14. This matches up. That is why I'm going from the new column to the original. It makes it a lot easier and it'll prevent you from making any mistakes. So for the x column in particular, anytime the x's are changing, you always want to take the new column on the left and compare it to the original. How did they get from the new column to the original? And when you want to double check it, you can always set an equation for whatever you have now in the parentheses and set it equal to all of the originals, all of these. So on that other page, let me go back. It literally said, write the equation for the table in terms of f of x. So this is what I want to see on your tests, quizzes, and homework. So for question 11, I want to see you write k of x will equal. Okay, well, all we did was we took half of every x for f of x, the function. So we're going to write that as f of 1/2 of x. On your tests and quizzes, guys, this would be your answer. If you want to write this as x over 2 instead of 1/2 x, I'll still give you credit, but this would be your answer. We're going to look at a couple more questions. Let's look at question number 14. First thing you want to do is take a second and compare the x column in f of x with the x column in m of x. Are these the same? No, gross. Okay, so we're going to have to change the x's. We're also going to need to look at the y column for f of x and the y column for m of x. Do these change? Oh, great, they do. Okay, so it looks like in this problem, both the x's and the y's do change. So again, on the back side of my page, I'm going to flip it over and I'm going to write out all of the x's. And remember, for the x's, I'm going to start by putting the new x's first, and then I'm going to put the originals. So let's start that one off first. Don't worry about the y's just yet. Yes, I know I've already cheated and I've already put up my new and original column, but pause the video, rewrite it, and let's go ahead and look at the transformation that happens. Okay, so just take a look at it and think. How am I going to get from negative 11 to negative 7, negative 8 to negative 4, all the way down from 2 to 6? If you're having trouble, start from the bottom. Look at these two. These are both positive. It might help. How are you going to get, for instance, from 2 to 6 and from 1 to 5? Okay, well, let's think. Especially if I start at the bottom, because I don't mind negative numbers, but if I have positives, I'll definitely deal with positives first. Okay, if I go from 2 to 6, I can multiply by 3, and that will give me 6. Okay, so let's try multiplying by 3. Whatever I choose, it has to work for every single one of the other values, going from the new to the original. So if I go from 1 times 3 to 5, that's not going to give me 5. 1 times 3 is 3, not 5. Okay, so I can't multiply by 3. What's another thing I could do instead? Let's see if we add 4. If I add 4 here, 4 plus 2 is 6. If I add 4 here, 4 plus 1 is 5. If I add 4 here, be careful, 4 or negative 1 plus 4 will give me 3. If I add 4 for every single problem here, I will get the original function. So if I add 4 to each of the problems here, I will get the original function. And that's what I want to see. If it doesn't work for one of the questions, guys, you have to choose another number. But luckily for us, all of these numbers will work. So I'm going to make a little note up here at the top. For all of the inside transformation, we're going to do x plus 4. We're going to add 4 for that x plus 4 inside. And I'm going to make a little note on the front side too. I forgot to do that. We're changing inside and outside. Make that note because it'll help you with remembering what you have to do as a checklist. Okay, so now let's look at the outside. So let me scroll back down. This is question 14. Now let's look at the outside. Okay, for the outside, if you think back to the first page and technically the other problems that we've been doing, whenever we're changing the y's, we're not having to do opposite operations or anything. We're not having to solve. We're just having to simplify. So we literally take whatever's in front and whatever's behind it, and we just multiply it or add it or subtract it to y. That's all we're doing. So for these questions, especially for the y's, so please pay attention, whenever you're looking at the y's for these, you're no longer going to go from the new to the original. Whenever you're looking at the y's, you're just going to look from the original to the new. How are we getting from the original values of negative 2, negative 6, all the way to 8? And how are we getting to all of the new y values, which are 6, 18, all the way down to negative 24? So keep in mind, when you're looking at the x's, it is extremely important that you go from the new coordinate in your new table to the original, because that is compensating for the inverse operation you would have to do when you're solving. For the y values, you don't have that problem, so that's everything over here in green. The inverse operation does not apply to these. All you're doing is you're taking the values that you have and you're going to actually simplify. That's all. Remember, these are the y's. These are your new ex or new boyfriend, girlfriend. They're not your exes. New boyfriend, girlfriend tells you exactly what they need to. So let's think. Pause the video if you need to and think, because I want you to find these answers on your own without me. How am I going to get from negative 2 to 6, from negative 6 to 18, all the way down to 8 and negative 24? How am I going to get to each of these? If you like, you can try with the positive ones down here, but eventually it's going to turn negative. So hopefully you're thinking for sure, you're probably going to have to maybe add or subtract or multiply or divide. You're going to have probably a negative somewhere. How am I going to get from 8 to 24? Ooh, I could technically do some adding and subtracting, but I'm telling you now, the number that I add or subtract will not get me. That same number will not get me from 3 to 9. Let me think. I think I can multiply these by -3. -3 times 8 is -24. -3 times 3 is -9. -3 times 2 is 6. All of these, if I multiply them by -3, I'll get my answer. It'll change all of the negatives into positives and all of the positives into negatives. So at the very top of my page, remember, we are multiplying all of these by a -3. So think about it. If you're multiplying by a negative number, really any number, if you're multiplying for y, how are you going to write that? Well, if you think about what we did here for question 7 on the first page, anytime we're multiplying, we literally stick it right in front of your function of x, your y. So for this question, remember how we have that -1/2 times your function that was being added or subtracted? That's how we're going to write question number 14. So for question number 14, let me scroll down. For question number 14, I'm going to multiply this problem by -3. This is what I need to write. So keep in mind, this is going to help my graph add 4. So it's probably going to move the graph to the left 4. And it will also multiply it by 3, which means it's going to have some kind of stretch or compression. So right here on the other side of the page for question 14, let me write my composition or my function notation, with my correct transformation. So we're going to have m of x is equal to, we're going to have -3 times f of x. Remember, because that's going to multiply every y value that you have by -3. In that parentheses for x, we're going to take that x and we're going to add 4. And remember, that's going to be technically moving it to the left or right. This, if you're like, wait, shouldn't this be something different? Remember, we're taking this x plus 4 and we're using it by setting it equal to all of the original x's. That's technically what we're doing in order to get all of these. This would be your answer. So, last question that we're going to do together is question 15. So with question 15, I'm going to zoom out and I'm going to compare the original graph to the transformation. First thing I want to check is to see if the x's change or the y's change, because if they do, it tells me, okay, do I need to look at new versus original or original versus new? What am I looking at? Okay, so for the x's, notice that every x changed. I see all those decimals, gross. Okay, so we have to change the x's. Let's look at the y's. Gross, these y's changed too. Okay, so 15 is just like 14. We're going to have to change everything. So on a separate sheet of paper, I'm going to go ahead and write the x's, and I'm also going to write the y's. Yes, I've kind of cheated and I've already put all my answers, but go ahead and pause the video, and I want you to notice that I put all of these in improper fraction form compared to decimal. It's going to be really easy for you guys to see the transformations happen or the changes happen as they're written in fraction form compared to decimal. So go ahead and pause the video if you need to and write out the new or the x's and y's based on the tables that we have. So all of this stuff to the left, these are my x's, these are my y's. And remember, when we're looking at the x's, these are the new, and we're looking at the original. So we're going from new to the original. So take a second and look at it. How am I going to go from new to the original? I usually start with adding or subtracting first. And if that doesn't work, then I usually go to multiplying or dividing. Okay, so first thing I think of is if I was going to go from -1 to -4, I could do that by subtracting 3. The issue is if I was to probably subtract 3 by 1/2, okay, I'd have to find a common denominator, which would be -6/2. That's not going to give me 2, so I can't subtract. How can I get from the new to the original? Well, let's see. If I was to multiply by 4, these would cancel. And if I was to multiply by 4 here, this would give me -4. It looks like I might be able to multiply by 4. Make sure you double check first that you wrote these correctly, and also that you can actually simplify them. Because even for this next one, I can reduce this to give me 2. Negative 1 times 2 is negative 2. Multiply this by 4. All of these, I'm going to multiply by 4. Double check. Make sure that you can actually get all of these values if you multiply by 4. Yeah, you should be able to get all of them to equal the original graph that we have on the right-hand side. So in the function notation part at the top of the page, I'm going to put f of 4x. In that parentheses, for every original x that we see, we're going to have to set that equal to 4x. When we set 4x equal to 7 and solve, we're going to get the new x value that we have over here on the far left. So this will work. Now we need to look at the y's. Okay, so for the y's, I need to see how am I going to go from the original graph to the new. And these are looking at the y values. Remember, y values, we can go from the original to the new. I'm going to go to each of these. Take a second and think about it. Usually adding and subtracting is a good place to start, and then multiplying and dividing is another place to go after. But adding and subtracting is usually a good place to start. Okay, well, can I add or subtract anything from the original to get to the new? I mean, I could try to add 1. If I add a positive 1 here, that will give me negative 1. But if I add 1 here, that's not going to give me negative 3. That's not going to work. Okay, adding's probably not going to work. Subtracting's probably not going to be any better. I see this fraction. I might have to divide. How am I going to get it from 2 to 1 if I'm dividing? All I would need to do is divide by 2. And luckily, it stays negative when I divide. Let's divide here. It stays negative. 6 divided by 2 is 3. If I divide here, that's going to stay 15 over 2 because I can't simplify. It looks like all of these can be divided by 2. So all of these questions I can actually divide by 2. So let's add this to the top of our problem. We're just going to have to take whatever the y value is and divide it by 2. So at the front, I'm just going to multiply it by, okay, well I could put it as a fraction, but I'm just going to multiply it by 1/2. This is the transformation that's occurring. So on the front side of the page, the front side that I was actually looking at, for question 15, I want to make a note because I forgot to do that before. This is an inside and outside change. And on that inside and outside change for w of x, which is the new graph, I'm going to write out the transformation that I have, which is going to be 1/2 times f of 4x. This is my answer. On your checking for understanding assignment, if you have one, so check Canvas to make sure, check to see if you have to do, well, you should have to do questions 13 and 16. So if you want to, pause the video and do questions 13 and 16. Remember, I do not have the answer posted right after this video's been unpaused. After you finish, post it on GoFormative or check Google Drive to see if the answer key is posted there. That's pretty much the end of the video. So the questions that I have highlighted in green, those are for your checking for understanding if you have an assignment. If not, check to see what other practice questions you can do. The remainder of this page is extra practice.